We have triggered the methane bomb. A hidden danger has now awakened under the ice of the Arctic. And while we humans continue to be its #1 trigger, it's not us alone who is responsible for this. Nature also plays an important part here. The so-called Arctic Death Zone, a region spanning northern Canada, Siberia, and Greenland, is rapidly losing ice. In just over 2 decades, the area has warmed twice as fast as the rest of the world. It may seem like a little statistical detail, but it's a detail that conceals a much greater problem. Because in these regions, something is slowly waking up under the ice. Something that was slumbering peacefully until now. Something that, if awakened, could trigger a real catastrophe. A runaway warming feedback loop. The methane bomb. There are trillions of tons of methane stored in the icy soils of the Arctic. In the barren landscapes of northern Canada, Siberia, and Greenland, a silent threat is stirring beneath the surface, frozen in the icy grip of the Arctic Circle. Beneath the frozen ground lies a treasure trove of methane, a potent greenhouse gas that could potentially trigger a catastrophic feedback loop. This hidden danger has remained dormant for millennia, patiently waiting for the right conditions to awaken. But now, with the drastic changes in our climate, the delicate balance that kept this sleeping giant at bay is starting to unravel. As temperatures rise, the permafrost, the permanently frozen layer of soil in these high latitudes, is thawing, releasing the trapped methane into the atmosphere. This phenomenon, known as the methane bomb, is a ticking time bomb that could accelerate global warming to dangerous levels. To understand the full scope of this impending crisis, we must delve deep into the science behind the methane bomb. First, let's examine the makeup of the Arctic landscape. The top layer of the soil, known as the active layer, thaws during the summer months, allowing organic matter to decompose. This decomposition process releases carbon dioxide, water vapor, and methane into the atmosphere. As these gases rise, they contribute to the greenhouse effect, trapping heat within the Earth's atmosphere and possibly accelerating climate change. Methane is particularly potent as a greenhouse gas, trapping more heat per molecule than carbon dioxide. However, its lifespan in the atmosphere is relatively short, breaking down naturally within a decade or so. Despite its short lifespan, methane has a significant impact on the atmosphere. Its ability to absorb and re-emit radiation in the infrared spectrum makes it highly effective at trapping heat. Even small increases in methane levels can have profound implications for global temperatures. So how do we measure the impact of methane emissions from the Arctic? Enter the Global Warming Potential, or GWP. This metric allows us to compare the impact of different greenhouse gases by converting them into carbon dioxide equivalent. For example, 1 molecule of methane is considered to have a global warming potential 23 times greater than 1 molecule of carbon dioxide. By understanding the GWP of methane, we can better assess the potential risks associated with its release from the Arctic permafrost. It's important to note that while methane has a high GWP, its total contribution to the greenhouse effect depends on its concentration in the atmosphere. Currently, methane accounts for about 10% of total greenhouse gas emissions. However, emissions from the Arctic permafrost are relatively small compared to human-related sources such as fossil fuel combustion and agriculture. Nevertheless, as temperatures continue to rise, the rate of methane emissions from the Arctic could increase, potentially amplifying the greenhouse effect and accelerating global warming. This brings us to the critical tipping point that scientists fear could be reached sooner than anticipated. As global temperatures approach certain thresholds, the release of methane from the Arctic could trigger a positive feedback loop. Imagine a snowball rolling down a hill, gaining snow and growing larger with each rotation. Similarly, rising temperatures lead to the thawing of more permafrost, which releases more methane, leading to further temperature increases and more methane release. This cycle could potentially spiral out of control, resulting in runaway global warming. But why should we be particularly concerned about the Arctic region? What makes it such a hotbed for this potential disaster? The answer lies in the unique conditions found in the Arctic Circle. The region is characterized by extremely low temperatures that have allowed vast amounts of methane to accumulate in the soil over thousands of years. As the Arctic Circle warms at an alarming rate, this methane is being released, adding to the growing concern of the methane bomb. The Arctic Circle holds the key to understanding why this region is such a hotbed for the potential methane bomb. The unique conditions found here allow for the preservation of vast amounts of methane in the soil. As temperatures rise, the delicate balance of the ecosystem is disrupted, leading to the release of this potent greenhouse gas. It's crucial to understand the factors that make the Arctic Circle susceptible to the melting permafrost and subsequent methane release to effectively address this issue. One key factor is the unique geographical location of the Arctic Circle. Its proximity to the North Pole means that it receives very little direct sunlight, resulting in consistently low temperatures. This creates the perfect condition for the formation and preservation of permafrost, which can remain frozen for extended periods. Additionally, the Arctic Circle is home to a variety of ecosystems, including tundra and ice-covered regions. These ecosystems are characterized by low-growing vegetation that contributes to the accumulation of organic matter in the soil. As this organic matter decomposes, it releases methane, further contributing to the potential methane bomb. Furthermore, the Arctic Circle experiences a phenomenon known as permafrost thaw. As temperatures rise, the permafrost thaws, releasing the trapped methane into the atmosphere. This creates a positive feedback loop, where warmer temperatures lead to more permafrost thaw and subsequently higher methane emissions. This cycle can potentially amplify the greenhouse effect, leading to further temperature increases and exacerbating the issue. To effectively tackle the problem, it's essential to understand these unique factors that make the Arctic Circle susceptible to the melting permafrost and the subsequent release of methane. By studying the geographical, ecological, and climatic conditions of the Arctic Circle, researchers can develop targeted solutions to mitigate the risks of the methane bomb. The impacts of the Arctic thaw extend beyond just the environment. Rising temperatures and shifting permafrost can also affect the lives of the indigenous communities that call this region home. These communities often rely on the stability of the land for their traditional ways of life, such as hunting and fishing. However, as the permafrost thaws, it can disrupt these activities, forcing communities to adapt to new and unfamiliar ways of living. Moreover, the economic implications of the Arctic thaw cannot be overlooked. The melting permafrost poses significant challenges to industries such as oil and gas exploration, which require stable ground for infrastructure. As the permafrost thaws, these industries may face setbacks and economic losses, impacting local economies and livelihoods. Despite the daunting challenges posed by the methane bomb, there is hope on the horizon. Researchers around the world are working tirelessly to understand and mitigate the risks associated with this phenomenon. One promising avenue of research focuses on developing innovative technologies to capture and store methane emissions from the Arctic. By preventing the release of methane into the atmosphere, we can reduce its contribution to the greenhouse effect and slow down global warming. Another crucial area of research involves exploring the potential impact of climate change on the Arctic permafrost. By studying the factors that influence permafrost thaw, scientists can develop strategies to preserve the existing permafrost and prevent the release of vast amounts of methane. Moreover, international cooperation is essential to address the transboundary nature of the methane bomb. Collaborative efforts between nations can help share knowledge, resources, and best practices for mitigating this global threat. In conclusion, the methane bomb poses a serious threat to our planet's delicate climate balance. While the Arctic Circle holds the key to understanding this phenomenon, it's important to recognize the far-reaching impacts it has on our world. From the environment to the economy and the livelihoods of indigenous communities, the Arctic thaw affects us all. By investing in research, promoting international cooperation, and embracing innovative solutions, we can work together to protect our planet and ensure a sustainable future for generations to come. Now check out another video that's been recently uploaded. You can watch it by clicking the link on the screen. Leave us a comment and don't forget to subscribe.